Chapter 1, sum number 1. Let f equal f from r thence to r be defined as f of x is equal to 10x plus 7. Find the function g from r to r such that g composition f equal to f composition g equal to ir. Solution. Given f of x equal to 10x plus 7 and g composition f equal to f composition g equal to ir. Therefore, g from r thence to r is the inverse of f from r thence to r. F from r thence to r. Now because it's an identity function, g composition f is equal to I composition g is identity function of r. So g is inverse, f is inversible, that inverse is g. Let y is equal to f of x equal to 10x plus 7 is given. Now y is equal to 10x plus 7, then x 10x is equal to y minus 7. So x is equal to y minus 7 divided by 10. Here f of x is equal to y, which implies x is equal to f inverse of y. Therefore, f inverse of y is equal to x equal to y minus 7 by 10 by 1. Therefore, f inverse of x is equal to x minus 7 by 10, which implies g of x is equal to x minus 7 by 10 is the inverse of the function f of x. Question number 2. Let f from w thence to w be defined as f of x is equal to n minus 1 if n is an odd and f of n is equal to n plus 1. Sorry, here f of n is equal to n minus 1 and f of n is equal to n plus 1 if n is even, so that f is inversible. Find the inverse of f. Here w is the set of all whole numbers. Solution. F from w thence to w defined as f of x is equal to n minus 1 if n is odd, n plus 1 if n is even. If n is even. First, we saw that f is inversible. Therefore, we prove that f is injectivity and surjectivity, or f is 1 1 and on 2. First, check the injectivity of the function. Injectivity. Here different cases will arise. First, case 1. Let n, m be two odd numbers such that f of n is equal to f of m. Now n and m are odd numbers, then f of n is equal to n minus 1 and f of m is equal to m minus 1, which implies n is equal to m. This is case 1. Now case 2. Case 2, let n, m be two even numbers such that f of n is equal to f of m, which implies here n and m are even numbers. Therefore, the function f of n is equal to n plus 1 and the function f of m is equal to m plus 1. So, n plus 1 equal to m plus 1, which implies n is equal to m. Case 3. Let n is even and m is odd, such that f of n is not equal to f of m. Yes, here f of n is equal to n plus 1, not equal to m minus 1. The functions are different, which implies n is not equal to m minus 2, which implies n not equal to m. F of n not equal to f of m, then n is not equal to m. Case 4. Case 4. Let n is odd and m is even. Now the values are different. N is odd and m is even. So the functions will be different, such that f of n is not equal to f of m, which implies n is odd. The function n minus 1 is not equal to m is even, m plus 1, which implies n is not equal to m plus 2, n not equal to m. Therefore, if f of n is equal to f of m, n is equal to m. F of n is not equal to f of m, n is not equal to m. Therefore, f is 1 to 1 or injective. Next, going to prove f of x is onto or surjective. For surjectivity, let n is odd, then f of n is equal to n minus 1 is even. Therefore, any even number 2 are in the codomain. W is the image 2 r plus 1 even in the domain W. Next condition for n is even. If n is even, then f of n is equal to n plus 1 is odd number, is odd. Therefore, any odd number 2r plus 1 in the codomain is the image of 2r, that is even in the domain W. Therefore, f is on 2 or surjective. Hence F is a bijection. Therefore F is inversible. Now going to find F inverse. To find F inverse, let us define G from W thence to W, because both the domain and codomain are W, by G of M equal to M minus 1 comma if M is odd and M plus 1 if M is even. When N is odd, when N is odd, G composition F of N equal to G of F of N. F of N is equal to N minus 1. Then G of N minus 1. Here N is odd, so N minus 1 is even. N minus 1 is even. So the function G of N, M, G of M is M plus 1. So this is equal to N minus 1 plus 1. This is N. Therefore G composition F of N is equal to N. Next one, when N is even, G composition F of N equal to G of F of N. N is even, the function F N plus 1. So G of N plus 1 is a given function in F. Now N plus 1, N is even, therefore N plus 1 is odd. So G in the function G of X. In G of M, M is odd. Then the function G of M is equal to M minus 1. So this is equal to N plus 1 minus 1 is equal to N. Therefore G composition F of N is equal to N. That is G composition F is equal to IW. Therefore G is the inverse. Now find F composition G of M when M is odd. Then F composition G of M, G of M is equal to M minus 1. So F of M minus 1. This is equal to then F of M minus 1. Here M minus 1 is, here M is odd, M minus 1 is even. Therefore F of even number M plus 1. So M minus 1 plus 1. This is equal to M. Then when M is even, then F composition G of M equal to F of G of M. This is equal to F of, here M is given, then G of M is equal to M plus 1. So M plus 1 is odd. So F of odd value, F of N, if N is odd, the function is N minus 1. Now M plus 1 is N, is odd number. Therefore M plus 1 minus 1. This is equal to M. Therefore F composition G equal to, G composition F is equal to IW. Therefore G is the inverse of F. Now find the F inverse. Hence G is the inverse of f, that is f inverse equal to g. Hence, here g also the same functions. Hence, inverse of f is f itself.